Okay, so we're going to talk about stem and leaf plots, another way to display data. Making a stem and leaf plot. Okay, so we're going to make a couple of these today, but to start, we use these to see how data is distributed, and you're going to see that when we start looking at these. Okay, the stem represent the greater place values, so the leaves must represent the lesser place values. Okay, so I want you to take down this set of data, and I will read it for you, so it helps you, because we'll make an ordered stem and leaf plot of these video game prices. So here I'm going to read it, take it down as we go. Each of them is a dollar amount, and we start with 40, 15, 19, 10, 24, 15, 39, 50, 35, 20, 43, 36, 30, 24, 27, and 29. Okay, so as we look at this set of prices here, what is this, the cheapest video game? Can you find it?
$10.
Good, it looks like $10. And the most expensive?
50.
Looks like 50. Good. So when we set up our stem and leaf, we want to make sure that it can include these two pieces of data, the least and the greatest. And then we don't need a lot of things beyond those extreme ends of our range, right? So let's put together a stem. Now the stem would be the greater place value. What is the greatest place value in this set of data?
50.
And so the greatest place value in the number 50 is it the ones place or the tens place? It's the tens place, right? And that is a 5 in the tens place. So our stems can be giving us the tens place, right? We want to make sure we have 5. The smallest number we noted was 15, right? The smallest number. So the smallest stem we have could represent 10, right?
Isn't the smallest number 10?
Oh, I'm sorry. I underlined the wrong one. You're right. It's 10. It still has a place value of 10, though. We don't really need a 0 in our stem, do we? We don't have any video game less than $10. So, good. 10, 20, 30, 40. These are all of the stems that we might have leaves for. Okay. So now we're going to start by making just an unordered stem and leaf. We're just going to start at the front of our list and say, here's a $40 video. So cross it off, and we can represent it by putting a leaf of 0 next to the stem that represents the 40s place, right? And we have 15, so we'll put a leaf of 5 next to the tens place. We have a value of 19, so now rather than writing 19, do you see we just put a 9 next to the 5 leaf? Do you see that? So now we have 15 and 19 in that, on that stem. So what will we do with the 10? Where will we put that 0?
Didn't we already do the 10?
No? We did 40 down here.
Would you leave it after 9?
It would come after the 9. That's right. That represents 10. 24 would go next to the 2. A 4 goes next to the 2. 15, we have another 5 leaf. 39. 39. Good. So you can see that we're just putting the ones place for each of the values in this set of data. 35 goes on the 3 stem, right? 20 we show with a 0 on the 2 stem. 43, 36, 30 has a 0 on the 3 stem. 24, 27, and 29. Okay? You understand how we got that? This is called unordered. I mean, we do have the stems in the correct order, but what is not in correct order?
The leaves.
The leaves. So let's go make it in an ordered stem. So we will have the same stems, won't we? 1, 2, 3, 4, and 5. But now let's put the leaves in the correct order, okay? So who can tell me the smallest, or for stem 1, can you give me the list in order, Sarah?
0, 5, 5, 9.
Yeah, 0, 5, 5, and 9. 5, 0, 9, 5, there we go. And how about for the 2 stem, Carly?
0, 4, 4, 7, 9.
Let's see, 0, 4, 4, 7, 9, good. And Sophie for 3.
0, 5, 6, 9.
0, 5, 6, 9. 0, 5, 6, 9, good. And then look at the 4 one is in order, isn't it?
So
We have
the
40
5.
and 43, 40 and 43, and then we have 50. Okay, there's one other thing that we want to have for our stem and leaf, and that's a key. So down here underneath it, we'll write key. And we will say that, give me some number from this set of data, Sarah. Just any number, pick a number.
4.
Say it again.
4.
From this set, I don't see a 4, I see a 24.
Oh,
You want to go with 24? So do you see how we read that as 24? Okay, so we could say this, 2 with the trunk and 4 equals 24. So there is a key if somebody doesn't understand what's going on with this stimuli. Okay? Good. Now that we have them in order, we can find some other statistical information from this. Like, could we find the range? How do you find the range? Do you remember?
You subtract from greatest. From least from greatest.
Right. So what is the greatest, everyone?
50.
And the least?
10.
So the range is
40.
40. Good. We could find the mode. That's a fun one to find. Do you see which value happens most frequently? Or values?
24, 15.
24 and 15. That's right. Okay, so we have 24 and 15 for the mode. And then we could find the median as well. Because they are in order, look at this. We are going from 10, we can say 10, 15, 15, 19, 20, 24, 24, 27, and so on. We can just count the leaves. How many leaves are there?
16.
There's 16 total leaves. So if we start from the very beginning, we would count how many places to find where the median is. 8. 1, 2, 3, 4, 5, 6, 7, 8. But because it's an even set of data, the median will be somewhere between the 8th and 9th, right? And so what are these numbers?
27, 29.
Right, 27 and 29. So what is the mean of 27 and 29? Right in the middle, 28. Right, so the median is 28. You simply took the mean of 27 and 29. Okay? Now we could find the mean of the data. How would we find the mean? That's right. Add them all up, divide. Did this help us with making that easier?
Yes.
I don't think so. Do you think it did? I mean, really, you could just take the original list, add them, and divide by 16, right? This doesn't really help with finding mean. But it does help with finding median a little bit because it got them in order. And then mode was easy to see, wasn't it? So, not mean. Mean was tougher. Okay, we're going to make a double stem and leaf plot now. Woohoo! As if single isn't enough, right? And so we have phone calls made by 2 kids, Kenyon and Jason. And this list shows you the number of minutes they spent on their last 15 phone calls. We want to find out, in general, who made longer calls, Kenyon or Jason. And we'll do that by making a double stem and leaf plot. Okay? So pause the video and take down this data. Okay, so to make the double, you're going to have Kenyon on the left and Jason on the right of a big old trunk that shows our stems. Okay? Once again, we want to know kind of what is this range. So the smallest number of minutes, does anyone see it? 5. And the largest number?
31.
Or here's a 34, right? So we go anywhere from 5 minutes to 34. So what do you think we should start with our stem? And so what would we put in the stem for a single-digit number like 5? Probably 0 in this case, right? So nothing in the tens. And then we go all the way to the 30 minutes, right? Nothing in the 40s. So maybe that's a big enough stem for us. And so now we can just start with Kenyon and come off the left side for Kenyon. So Kenyon made an 8-minute phone call, a 12-minute phone call. It looks different, doesn't it? Almost looks like 21, but it really, you have to read it from the stem to the left. 8-minute, 17-minute, 5, 28, 16, 23, 29, 14, 21, 34, 16, 28, and 31. You kind of have to read backwards. Now Jason, 31, 16, and then 24, 28, 7, 12, 5, 11, 5, 13, 14, 6, 11, 19, and 24. Whew. Everybody got that? Okay, oh, let's put a key down below. Let's do this. If you see this, 8/2/4, that means we have a value of what for Kenyon? 28. And for Jason, we have a value of 24. Okay, so kind of an interesting key that's helpful. Okay, so the question was, who made longer calls? And can you just look at the leaves here and draw a conclusion on who made longer calls? Can you? Everybody look. I'm going to have you say together who you think made longer calls. Ready? 3, 2, 1.
Kenyon.
Okay, you all selected correctly. And we didn't even put this in an ordered way, right? We don't even need to put it in an ordered stem and leaf. We can leave it as is, unordered. But you can see more leaves for Kenyon are falling in the 30s and the 20s, right? And Jason has a lot more in the 10s and 0s. So, very good. So the answer is Kenyon made more phone calls. Okay? And there you go. Have fun.